The parts here on the table, you see an 1/8 inch of aluminum with quite a bit of dross on the edges, laser cut. Then some very clean 3/8 stainless steel and steel. Some 1/4 inch. This 1/4 inch for that edge would require some belt sanding in order to remove that dross, which would be the machine over there. And then we have here some 1/4 inch, some very, very small parts that are going to be difficult to hold. And some of them have some dross and some of them are very clean. In order to be more aggressive, we are going today with our purple block. And you see the serration on the top, which gives it a little bit more flexibility for inside contours. One of our features of special blocks. This is a ceramic material which makes a very smooth edge and at the same time gives you a larger radius. Pretty aggressive. So, without further ado, we will close the machine and we will set up. So this is a medium setting, which is probably good for the small blocks, but we will go a little bit more aggressive afterwards for the 1/8 inch. And then here we have our material thickness. We'll start with the aluminum. Turn the machine on. And now, in order to be maximum aggressive, what I'm doing is I'm turning the belt down until I hear it slightly touching the belt. And I want you to listen to the sound. Up. On. So at that point, because this has a lot of dross, we are running this at an angle, and we are running this at a minute. And then afterwards, the second piece, we are going to run at 3 feet a minute, depending on how this one turns out. You can now hear the brushes again. Very nice radius on the edge. So what I'm always concerned about is what it would look like here, because this is where you are parallel to the brush. But even here, we have a good radius. This has been running very, very hard. So now we will see whether we can get the same result, running a little bit lighter, about a 1/2 millimeter lighter, and about a foot per minute faster. So this is how and then hard. So this was super hard, and I will go. Find myself a Sharpie. So this was heavy pressure. I need to go and pick up my part back here. So this is very nice. By far not as much temperature. So if this here was heavy pressure, it was heavy pressure plus. This one was still heavy. But this one was 3 feet per minute, and this one was 2 feet per minute. Now, for the reverse side, what we're going to do is we're going to do something even different. I actually like this result almost better than the result on the other part. So, what we're going to do is we're going to go to 5 feet per minute. We're going to keep the pressure here the way it is. We are off the belt. Maybe I'll take another 2 pins off until I don't hear it anymore. Right? We have, of course, full cross belt speed. And we're going to run the reverse side at 5 feet per minute. So there is no dross, and it should work just fine. Of course, at 5 feet per minute, parts disappear very quickly and reappear by the side cross. And you see here also an excellent radius all the way around the part. Again, it's aluminum. I'm not sure what series it is, but it looks like 5052 to me, something like that. So this is the non-burr side. Or NBS, right? So this is also the NBS, and that is 5 feet per minute medium pressure. 5 feet per minute. Okay. So, moving on, we will first run this piece again, very, very heavy and very slow to see if we can remove this dross. I don't think it will be possible, but we will give it a try. So we go back to 2 feet a minute. The dial indicates about 1 foot per minute less than what it actually is. It's obviously just a potentiometer from 1 to 10. And we will go back. First of all, we'll go to the material thickness, 1/4 inch, right? And we will go back to our heavy setting right around 47, which is about 160 thousandths below the surface. Now this is a larger part, this will hold, you can do that, but when you have smaller parts like this, or especially like this will not work anymore. Because they are thicker, you have a lot of lateral forces. For this we will need to reduce the cross belt speed, and we need to reduce the pressure, and we need to actually increase our conveyor feed rate in order to make the part stick. And even then it may slip. These parts, even though they are below 2x2, below our specification, I think we will be fine. They are 3/8 thick, so we will have to pay attention that we so this is how this part came out, and you see for most of it we have wonderful edge rounding, and actually on the outside contour we are clean, but on the inside contour we have a little bit of this drossness, and you either need to improve your cut quality here, or like I say, run it to about standard work. So now we'll demonstrate. So this was 2 feet per minute. We will demonstrate on the back side of the contour. course. So this was, if you remember, 2 feet per minute heavy. We like heavy because then we sell you a few more brushes. Not that the consumables are very high on this machine. Okay, and I have marked for you where I see some defects still. So now we are going to the 3/8. Now we need to do something completely different, of course. Now, take this. First of all, I need to go to the 3/8 material thickness. We need to lighten this way up to about 49, and I'm going to slow this down somewhat, and we're going to keep this at about 3 feet per minute. So then we can determine whether we have a little bit of part slip here or not. But you see the part holds nice and steady all the way through. Of course we are way lighter now, and also we have reduced our process speed to about 70 to 75%. Here's the result, and of course we have less edge rounding, but it is a perfectly deburred part. I think you will find it very pleasant. It's very cold to the touch. So what we will try on the reverse side, that was the reverse side here, by the way. What we will try on the reverse side, we will go back to full bearing. See if that holds well for us. And is that? So, keep up with our documentation. This was side 70% speed, light, 3 feet per minute. Obviously the speed doesn't matter on a part size like this because you're going to run hundreds of them through that machine. Even though with small parts like this you may have to run them double file left and right, single. So, and this was a non-burr side, also light, and 3 feet per minute, but 100% speed. So now, what we will do is we'll take this piece of stainless, which is even a little smaller than this, and what we'll do is, because it is stainless and it does have a little bit of burr, always at an angle, of course, make sure that you have nice compression. What we will do is we will increase the pressure a little bit to 48.9. So we are going about 40,000 people into the material. And you can now see that the part has kind of a little bit of a twitch to it, which is still fine. And we are running obviously full speed. So, and the 3 feet per minute may have been a little bit too fast, but here is the result. Actually, not bad at all. So, that was compared to this one. It was a burr side. It was medium. It was 3 feet per minute. And it was 100% speed. And now we will do the non-burr side here. And just for giggles, we're going to bring it down to 2 feet per minute. Going slower with small parts is not always a good idea because you give it more time in the transition from the pressure roll to the belt to twist. But these parts hold very nicely because we have a clean conveyor belt. Even though we ran aluminum before, Usually you're supposed to clean up after aluminum to get a little bit of the powder off the belt, which makes it slippery. But because it was only 2 parts, it wasn't so relevant. So here we come, and you see a bigger white line, which means it's a larger radius, and that makes all the sense in the world. Why? Because we went about 50%. And it is a non-burr side. So, this is the non-burr side, medium, 3 feet per minute, 2 feet per minute, and 100% speed. And this is how we go about the last one, these 4. Some of them have burr, some of them don't. This is the burr side, this is the burr side, this is the burr side, this is the burr side. So we'll try with this one first. Obviously, this is 1/4 inch again, so we need to come down. Needs very quick adjustment. Go to this. We keep it at medium, but we'll take our speed down, and we go to 3 feet a minute just to see what happens. Here you see the part switch again a little bit, but it seems to stay the course. Then as it makes the transition, it moves a little bit to the left, and then it makes the transition into the next belt, and you see it switching back and forth. So what we need to do for this part is we need to reduce our belt pressure somewhat, which is not going to hold well with some of the dross that you have on there. You see a little bit here at the entry of the cut, but the rest of the part is actually fairly nice and clean. You have less on the inside contours than you have on the outside contours. This is where the purple belts make a very good appearance. So we are going to take the next piece and are just going to lighten up a little bit to 48.5, but therefore to heat up the belt and see how that works. That actually moves the part more. So I'm going to have to reduce that belt speed again. As you see, it also rotates the part a little bit, but it keeps it going. That was a transition out of the back pressure roll. Overall, it didn't move too much. Fortunately, that we don't roll it. You can see the orientation came out in a different orientation. And of course here, the dross that we had on the part is nice and round, but not removed in this case. So here we are going to go slower again, but we are going to reduce the pressure and come further down the speed. And the part is more stable this way, even though it rotates under the back belt. And moving out. So at this point, we have very little edge rounding, and we have more of the dross left. So our first test was actually the most successful, but we were slower, but we were heavier all together and a little bit faster. So let's try this again. Oh, not so good with the heavy. And it doesn't move on. So at some point it's going to click. So what I'm going to do is I'm just going to speed the belt up in order to drive it out. So when we do this for the reverse side, of course, that makes things a little bit easier because it's a non-burr side. We can go lighter again. What would help if I would clean this belt with a little bit of alcohol? Then I need to bring the belt speed down, about 3 feet a minute. If I clean this belt with a couple of cracks with a little bit of alcohol, you see how I'm going left and right of the center in order to balance the pressure roll. Ultimately, there's a reason why we expect this machine to be at least a 2x2 for the size. Because if to hold a part reliable, you need to make the transition from the pressure roll to underneath the belt. You see a little bit of movement here in these parts as we go. Here they come. You see the white line around the outside, so the non-burr side. Very nice result. Just a little bit of edge mounting, but this is already enough for a good paint. So, and that concludes our test with the M1100C today from MetalFinish. I thank you for shipping those parts, and we'll return those to you tomorrow morning. Thank you.